Object-oriented design is the Roman numerals of computing. First of all, this code gives a clue about how important the object-oriented programming paradigm. Hello everybody, my name is Recep Tayyip Erdoğan. I'm currently a student at Akdeniz University in computer engineering, and I'll give a presentation about the philosophy of object-oriented programming. I will follow this content during my presentation. Let's begin. Programming paradigms are a way to classify programming languages based on their features. Languages can be classified into multiple paradigms. Basically, paradigms are divided into two groups: imperative programming paradigm and declarative programming paradigm. These are different programming paradigm approaches, but I will not talk about difference between them. I will focus on the imperative programming paradigm. Imperative programming paradigm is one of the oldest programming approaches. Programs written with this approach consist of clearly expressed commands. This programming approach deals with how the program performs an action, and it includes procedural and object-oriented programming approaches, as you can see. Object-oriented programming is a programming approach in which every function is abstracted as objects. Also, if one programming language supports object-oriented programming, that language is called high-level programming language. Many people believe that object-oriented programming is a product of the 1980s and created with C++ language, but this is completely wrong. Actually, Simula 1 and Simula 67 are two earliest object-oriented languages. While most of the advantages of object-oriented programming were available in the earlier Simula languages, however, it wasn't popular until C++. The object-oriented programming became popular with C++. One more important piece of information: Smalltalk was the first programming language that fully supported object-oriented programming. Also, you can see the example code of Smalltalk language. The next step in the development of object-oriented programming began in January 1991, when James Gosling, Bill Joy, Patrick Norton, Mike Sheridan, and others met in Aspen, Colorado, to discuss ideas for the Stealth project. If you are interested in this topic, I will add all links and references below the video so you can get more information about that. With object-oriented programming, we can provide manageability, flexibility in large projects. We can more easily debug code errors. We can use the properties of a class in different classes. And you can get much more ability with the object-oriented paradigm. To use this paradigm, you must be familiar with these concepts. You must also have procedural programming knowledge, because sooner or later you have to work with procedural code. Because procedural programming can work like an extension or an introduction to object-oriented language, instead of just being an alternative. With abstraction, application that details are hidden and only important information is shown to the user. Interior details are hidden. For example, we turn the key to start the car, but we don't know what happens in the engine when we turn the key. But we just turn the key to start the car. And this process called abstraction, because we are abstracted from unnecessary information about the inside of the car. Encapsulation. Encapsulation means hiding the class's information from the outside. We can do this using access specifiers like private or protected. Or we can use setter and getter methods. These methods provide access to variables defined in another class. So, if there is a part of the code that needs to be accessed, instead of opening the whole code, we open the part we want the setter and getter methods. What about inheritance? Inheritance means that information in a class can be passed on the subclass without having to be redefined. The class from which a subclass is produced is called the base class, superclass, or parent class. The subclass is called subclass or child class. For example, the laptop and desktop classes are a subclass of the computer class because laptop is a computer, desktop is a computer. Polymorphism. We can say polymorphism is that an object behaves like a different object. It can be of two different types. The first is that the same method can be used in different classes or methods with the same signature, but different content can be created within a class. So this is called overloading. Another variant is that an object has more than one form, like the deer. The deer class is considered to be polymorphic since this has multiple inheritances. Deer is an animal, deer is a vegetarian, deer is a deer, deer is an object. How can we use object-oriented paradigm? What we want to use is not a tool, but an approach and a paradigm. If you want to use the object-oriented programming paradigm, you must first use the object-oriented programming language. You can access the list of object-oriented programming languages by scanning this QR code from your phone. Let's practice a little. In this application, I will try to imitate computers with an object-oriented approach. Firstly, I will create a Java class in source folder and I will create this class main. Okay. As you know, every computer has CPU and memory. So I will create CPU and memory classes to define them. Let's begin with CPU. Just a minute. Okay. Class CPU, and CPU, as you know, has a name and frequency. Let's begin. Private string name. As you know, we are using private identifier because of encapsulation. Private string frequency, and we should create constructor. I will create constructor public CPU, and it will get name and frequency as a parameter. String name and string frequency. This frequency equals frequency and this name equals name. Okay, I created constructor, and I will create two string methods. Generate string, yes, and I will create now a memory class, memory, and as you know, memory has a type like DDR2, DDR3, and has a capacity 4 GB, 8 GB, 16 GB, like this. And I will declare attributes. Firstly, private string type and private integer capacity. Capacity. And I will create constructor for memory class, public memory string as type and integer capacity. Okay, this type equals type and this type equals capacity. Sorry. This capacity equals capacity. And I will create toString method for memory class. Generate toString. Yes. And I forgot the getters and setters method for CPU. First, I will create these constructors, getters and setters. Okay, I created, and I will do the same for memory. Generate getters and setters. Okay. I created two classes, CPU and memory, and we can create an object from this class. But firstly, I will create another class, uh, computer, because our example exists for computers. Let's begin. So class computer. Okay. As you know, all computer has a CPU and memory. So I will declare attributes firstly, CPU, and private memory, and I will create constructor. Actually, I use generate function and constructor CPU and memory. Okay, and I will create toString method. Yes, and we talked about inheritance. Uh, as you know, there are different types of computers, like laptop, like desktop. Laptop is a computer, desktop is a computer. So I will create two more classes, and uh, these inherited from computer. Let's begin class, for example, laptop extends computer. Why I'm getting an error? Okay. Uh, as you see, laptop is a computer, so I'm using extends keyword because laptop is a computer. This is called is a relationship, and I will create constructor for laptop. Okay, and I will create toString method again. Oh, sorry. String methods laptop. Yes. Um, let's configure. and I will create other class, desktop, and again extends computer because desktop is a computer, and I will create constructor, and I will create string method. You may not be familiar with this term of super. Let me give a brief information. The keyword super refers to the superclass and can be used to invoke the superclass methods and constructors. I mean, this super, this super keyword refers to superclass, uh, refers to computer class. And okay, I create laptop, desktop, CPU, memory, and computer, and okay, let's test this code. Firstly, I will create a CPU object from CPU class. CPU1 equals new CPU. We are using new keyword to create an object. Actually, let's pass parameters to the CPU constructor as i7 and frequency. This will be string 4700 megahertz. Okay, let's print the CPU1 to the string with using toString method. And, okay, run the main. Okay, as you know, we create a CPU1 object from CPU class, and CPU name i7 and frequency is 4700 megahertz. And I will create memory object from memory class. Memory 1 equals new memory, and as you see, parameters type first is string and second is integer, and DDR4 I will pass DDR4, and capacity, for example, 16. Okay, and let's print the screen to memory to see clearly. String. As you see, we create a memory object from memory class and type dd3. Oh, sorry, it will be DDR. Run it again. Memory type DDR3 and capacity equals 16. There's no problem. And I will also create laptop desktop object. Let's begin. Laptop, for example, my laptop is monster equals new laptop. I will pass the parameters CPU and memory because we used laptop constructor, and pass the parameter as a CPU object and memory object. So we should pass two objects as a parameter, and I will pass these objects CPU1 and memory1. Okay, and no problem. And let's see the master string. Let's print screen again. We will see laptop. As you see, we create a monster object from laptop class, and laptop computer CPU name i7, frequency 4700 MHz, and memory type DDR3 and capacity is 16. And let's create another desk object from desktop class. Desktop equals new desktop, and again we will pass parameter to desktop, and I will use same objects and memory1, and so desktop dot to string. As you see, we can see the properties of desktop computer. Desktop is a computer, and properties of CPU name is i7, frequency is 407,000 MHz, memory is DDR3 type, and capacity is 16. That's all. This is object-oriented programming paradigm, object-oriented approach to real life. As you see, object-oriented programming gives us the ability to imitate real life and many more capabilities, and I want to end my presentation with the following words. In theory, the difference between theory and practice is small. In practice, the difference between theory and practice is large. Thank you for your listening my presentation. I hope this presentation will be useful for you.